Hello to everyone. In today's lesson, we are going to see how to calculate for distance along great circles, which means along longitudes or along the equator. So to calculate distance along the great circles, knowledge about circles is needed. That is to say, you have to know how to find the circumference or the arc length of a circle when angles are in degrees. Circumference formula is C is equal to 2 pi r. Arc length is theta over 360 degrees times 2 pi r, which is equal to theta degrees over 180 pi r. And the radius of the Earth, which is represented by r, is equal to 6,371.0088 kilometers. Why are we saying 360? 360 is the angle of a complete circle. Theta degrees being the angle of the arc or angle difference between longitudes or the equator. And radius, r. Under Earth geometry, r is equal to capital R for radius of the Earth. So when you see a small r, we are going to replace it with 6371.0088 kilometers. That is along great circles. We have QR and the angle which is made by those 2 points. And you can see QR, when you are using circle properties, it is an arc. And you know how to find an arc. So this arc QR is along a latitude which is 0 degrees. And that is an equator which is the only great circle among the latitudes. Now here's a cross-section of this point. We are given this figure here saying calculate the distance from Q to R. Okay? What is the first thing you have to know? Find the angle theta degrees. How do you find it? You find that angle by looking at is QR along a latitude or a longitude. Okay? So from here we can see it is along the latitude, which means we are going to use the longitude values to find the difference between these 2 points. We'll go for the longitude where Q is. Q is on 46 degrees west and R is on 37 degrees east. Are they on the same side of the prime meridian? No. So this means we are going to add them. Okay, so 46 plus 37, here is the solution. The angle theta is 46 plus 37, which is equal to 83 degrees. Since this is just a circle, we are going to use the circle formula, which is C for the circumference is equal to 2 pi r. 360 degrees is equal to 2 pi r. 2 pi r, that is a circumference. So a circle has 360 degrees. What about when the degrees are 83 degrees? And that arc is QR. So we'll say 360 degrees is equal to 2 pi r and 83 degrees is equal to QR. Then you cross multiply. This is what we obtain. 360 QR is equal to 83 times 2 times r, which is the radius of the Earth, 6371.0088 kilometers times pi. For us to remain with QR, we are going to multiply both sides with the multiplicative inverse of 360, which is 1 over 360. When you multiply 1 over 360 on both sides, this side will remain with QR, and this side we are going to divide by 360, as you can see. Once you punch on your calculator, and here is the final answer. From here, you can see that we are just using a formula for circumference. So why should you worry about memorizing these formulas about, okay, no, the formula for calculating distance along great circles? So long you know how to find the length of a circle, you are done. You are home and dry, okay? This question can also be answered in this way, where you use arc length formula. So QR is equal to theta degrees over 180 degrees pi r. This is just a simplified version. It's one and the same formula, but this one is specific for the arc. You can also derive it from the circle formula, perimeter of the circle, which is circumference, okay? The same formula can derive it this way. So you can put in all those figures. Theta we know is 83. R there is 6371.0088 kilometers times pi. And then finally you have that answer, okay? Which is one and the same thing. So do not memorize formulas. Know how they are derived, okay? Or know how they are formed. In the next lesson, we are going to see how now to calculate distance along small circles, which are latitudes.